So I think I'm just going to get started, essentially. So I'm Tim Perry. I work for software. We're in London, also over here at Bristol. We do bespoke software development. So we're building all sorts of things for all sorts of people, for various strange reasons, buildings in JavaScript. So I'm going to assume most of you are sort of slightly familiar with JavaScript, a bit at least, but a bit of a recap of the history would be kind of useful. So it was originally written by Brendan Ike during the Netflix, i.e. wars in the mid-90s. It was written entirely in 10 days. They suddenly decided to win this war, they just write a whole new dynamic language, rush it through, get it out before I eat it. So that's 10 days from, oh, we need a language, let's think up a design and a spec and a concept, and then let's implement an interpreter and actually get the whole thing up and running straight away. And then they integrate it in the browser and ship it to us. There's then a little bit of fact mucking around and stuff, but every other browser implements it as well, based on what was kind of working at that point. And then a few years later, somebody standardized something that's sort of close to what everybody's already doing. And then 16 years later, we're still using this language based on 10 days of development and a lot of planning. It's not all bad. So something worse than JavaScript here was actually a prototype for Netscape built client-side PHP that never quite made it into the real world, fortunately. And this is the kind of standard summary of the situation. There's actually some somewhat challenging parts of JavaScript that cause some problems. I'm going to sound a little bit like I'm ranting about JavaScript through quite a lot of this, but actually JavaScript is quite nice, and I do quite a lot of JavaScript day to day at the moment. And it does actually have some really great bits. So things like dynamic typing, first order functions, proper closures and stuff are really popular at the moment. Loads of quite snazzy, exciting languages are doing them. Academia's been doing them for a long time, they're really coming into the mainstream. And JavaScript is actually quite a long way ahead in this sort of stuff. Which is great, and it's nice that the platform that everybody's using isn't terrible. Except some of the bits are terrible. So there's a whole load of selections of things in JavaScript that you just should never use. Like, it's clearly a mistake. If you depend on semicolon research, at some point it's going to bite you, and your script is simply not going to do what you expect it to do. There's quite a few bits of JavaScript that are actually quite complicated as well. So getting the hang of how this works and function calls is the kind of thing that when you're getting people into JavaScript initially, actually takes quite a lot of setup. Nobody instinctively gets it at all. It just doesn't quite work. There's some other things that all the other mainstream languages that people use for everything else are actually doing. Stuff like being able to define classes and normal inheritance kind of models. Cool optimizations. If you would try and be a functional language, you could at least properly do it and actually try and keep up there a bit. And any mechanism at all to build modules of code, which is obviously what I'm going to talk about in some more depth. So every other language really offers this, and without it you get quite a lot of trouble. But obviously, if you're going to try and design a language in 10 days, you don't think about people building fast applications out of it that you're going to need really easy. So this is kind of an example, which might be sort of readable, also quite bad JavaScript. So this is a fairly common kind of setup you get actually, certainly until recently for normal JavaScript applications. This is a coffee machine, which I'm going to use as a dubious example throughout, because we've got a coffee machine with a nice web UI on it, has a big button you click, and it makes coffee. Everything is controlled from JavaScript, so the coffee machine grinds your beans and it heats your water and then it pours your coffee. This is done with very simple model here. So we've got just an iterative list of steps, and we've done a tiny bit of abstraction and taken these steps out into separate functions that we'll refer to from a separate file up here. That's as much separation as we've got. This is quite nasty, and it's going to cause us some problems. It will take a very slight detour to explain these into the details of exactly how JavaScript does scoping and variables, which is one of these exciting warts that we've left with. Variables are flexibly scoped based on functions, which means they're available, they are local to the function you define them in, they're available in functions nested inside that, and if you define a variable inside a function, it's not available outside that. So as we've got at the bottom left, you can put functions inside functions, and variables are then available into the function out. Variables get declared if you use the var keyword, or if you define functions like this. There's local scope that works like that. Unfortunately, there's also global scope, which is totally different than normal. And essentially, if at any point outside the function you define a variable, or if you try and write the variable inside the function but you forget your 3 characters and don't put the var at the beginning, it actually defines it as a global variable. It's now everywhere, all the time. This is implicitly the same as this line, so attaching it to the window object, which is a global variable that holds all the global variables, which interestingly means, according to the spec, window has to be attached to window to window to window to window to window to window. So it's really easy to end up with globals everywhere, and JavaScript doesn't really have a concept of files at all, really. So a global is a global everywhere. It doesn't matter if you put it into whatever. Once you've written it once, everything gets it all the time. So this doesn't back and bites us because lines like this. So up here we do var sugars and var milk. We have some actual local variables. These we only need for a little bit. They're only going to last for function scope, and then they're going to disappear again. And that's fine. We ask how much sugar you want, how much milk, and then we ask again from the next person. Some things we want to persist. So we're tracking things like coffee grounds, this kind of thing. So there's state here that's held globally. There's no way of working out how that gets managed from this. To work out who's tracking the coffee grounds, we basically have to read all of the code. That's awful. I mean, that's not going to be fun. It could be managed by basically anything, so you can have a background thread, perhaps that's continually checking some hardware device that can see the coffee. You're going to have some system where every time you make a cup, you increment something slightly. You're going to guess. It could really do anything. There's no easy way to tell what's going on there at all. So you've got this completely invisible state that's shared through all of this. And similarly, if you kind of dig into some of these functions, here, when you pour coffee into a mug at that point, it stops heating water. So this is because, it can stop doing that anywhere. It's implicit state, it can be controlled anywhere we like. But if we want to add cancellation functionality, for example, to start heating water, then someone says, oh, I don't want coffee. Is this the only place for that to manage? Is there anything else that's going to catch it? Can we just put a stop in and that will work? Or actually, if we're not careful, is the coffee machine just going to explode at some point after that point? It's quite dangerous. You can't really tell, and you have to know everything to do anything, which is awful. And the basic conclusion of this is that global state makes this very hard to reason about. You can't see how anything interacts. You have to really dig right through all of your connections everywhere, all the time. And you want to try and encapsulate it instead, break into component parts that you can reason about. So you can describe explicit interfaces between these parts, and hopefully with some good design you'll actually get some quite clear responsibilities to independent parts, so you can instinctively say, hot water will be managed by this hot water component. I'll go and look at there. And when you're adding new ways to manage hot water, you put it in the hot water component. It's kind of solved itself. So this is kind of the first thing I'm looking for. So we can fix this a bit by moving towards kind of OO JavaScript, which I hope is the kind of model most people with some experience would sort of work towards. So here we separated them out into separate files, which as I said is basically meaningless from JavaScript point of view, because it's useful to us. And into sort of class equivalents. So stuff is just defined by functions. Here we've got a coffee machine, which builds a coffee grinder, a hot water source, and UI, and then hooks them together and kicks them off. And this is an improvement. That's great. We get a bit of structure here. The details don't matter, but this isn't a particularly terrible design. It's based on an example by Uncle Bob somewhere for like how to build an OO coffee machine translated across to JavaScript. So you can sort of get sort of okay stuff here. And it gives us what I also want to look for, the second reason, which is reusable bits of code. So we've got a hot water source there. I can pick this up and I can make it to a machine powered by JavaScript. Again, relatively easily, which is quite nice, quite powerful. Or you can swap out the UI for something that just knows when you want a coffee, just makes it for you, brings it to your desk, these kind of things. So if we can get proper components, we can click stuff together and we can put it into a whole new system very easily. But it still isn't perfect. If we dig in and we look at the individual components and expand them out, you can get something like this. So we've got a bean grinder that keeps some beans and has a grind strategy. and this kind of thing, and carefully explicitly exposes so that hot water source has an open tap function that it shows you and start using it. These kinds of things. In here, there are actually lots of dependencies implicitly that you don't really see from outside it. And these aren't so much components that these are using necessarily. They're just libraries that are around and extra things you need to have access to. So here we're using knockout up on the left, and a bead supply and growing strategy, which presumably is part of the machine. We've got a fluid dynamics calculator to manage our hot water and fully understand how it flows. And we've got jQuery, jQuery UI over here. And all of these are coming in from globals again. So we don't have any mechanism for hiding these, they're just visible everywhere. And we can't really see what any of these are using or what they need. There's no way to tell what you have to set up. And if you look at what you have to do to actually hook all these up, you have to stick a script tag for each one, and put them in here, and that's going to be quite painful. This is a toy, ridiculous application. But if it gets bigger, then you get so many more scripts, and every dependencies as well. And on and it goes, it gets much worse. And the even worse bit about this, beyond just managing a ludicrously long list, is that there's a lot of implicit dependency information between these back and forth. It defines an order here. So we've got one order that works, and we know that, that's great. There's no way to easily tell which ones depend on which ones from here, again, without reading all of the source. So implicitly we know various things we can probably get at it, but if we said that actually the bean grinder is now going to use a hot water source, the hot water source has to come up above the green bean grinder to define the globe, to make it available so we can use it. But do we know if we can do that? Would that mean that it comes after something it already depends on? If we do it wrong, you start getting undefined variables for your globals and things either outright break or do something wildly unexpected and you get yourself in a lot of trouble. So again, we're in a situation where we have to read everything to do anything, which is not very nice. And my third reason to try and get towards more modular code is that if we can be explicit about our external dependencies, then you can manage this kind of thing. This is kind of just an extension of proper encapsulation, but if you can say that if you can define what's actually internal to your module and explicitly say what is outside of your module and what is going to go outside of your module, you get a lot more control and it's much easier to manage this kind of stuff. So that's three things I'm looking for. I want to try and pull everything inside chunks of encapsulated state. I want to be able to pick these up and use them somewhere else very easily, and I want to be able to see what they depend on so that I can do that even more easily. The first way to do this, this is a fairly classic JavaScript pattern, is immediately load function expression. This is, I guess, idiomatic JavaScript, which doesn't say much for the state of JavaScript, but basically works on the fact that local variables are only really available if you've got a function scope, so why don't we just build a function? So what we're actually doing in the middle of this is embed a function. Right here. We take in jQuery and our grind strategy as parameters to it, so that lets us set the name of these. This creates local variables essentially within the scope that we can use. And within here, we don't have to worry about global so much. As long as we put bars in sensible places, we can do static analysis and watch out for that. We're going to get fairly easy encapsulation in this module, but we're not going to have too much trouble with that. We then have to put brackets around it, because in JavaScript, if you don't put brackets around it, it can interpret it as a statement, which you can't immediately do things with. It becomes a function definition that means something that's slightly different, so you can't actually use it. So we put brackets around it to make it a value that we can then play with, and then we actually call it at the bottom here. So inside we're taking jQuery and a grind strategy, and out here we say that we get those from these globals which must exist to make this module work. So we have to have a jQuery global available, and we have to have a coffee machine global that contains the grind strategy. So this coffee machine here is essentially namespace. We try to put a wrapper and just put the modules in there to at least improve the global situation a little bit, avoid collisions between names, at least to some level. And then the actual module itself can return a value which then becomes something that other things can depend on return, or we put that into the namespace. One thing I'm skipping out here is that namespaces are a bit of a hassle, so coffee machine has to exist beforehand, because if you try to just attach things to it before it's there, things will explode. And once this gets quite a lot longer, if you start getting a little Java root and you've got window.com box off like a coffee machine you've got right now, there's a lot of initialization there and checking the override that already exists. And it's just a bit of that. But this works. This gives us basically what we want. So things we encapsulate this like function, our dependencies are all clearly listed across the bottom. And we can reuse it. We can pick this up and put this somewhere else as long as we're sure the dependencies are already there. And we can see them. So it's not too hard to manage. But it's still much worse than every other language. So let's do a bit better. The real problems are that module loading and ordering still have to be managed manually. So it tells us what our dependencies are, but we've still got to actually put in script tags, get hold of all these things, and carefully reorder them to make sure that we're fulfilling each one of these dependencies in the right order, and somehow satisfy that. And we're still storing in global state, so we're still putting it out there on the window object all the time, leaving with namespaces in case you get conflicts, especially if you ever want to think about having two versions of the same thing. That becomes very difficult. And you have to just manually handle namespaces and this kind of stuff. It's quite a hassle. So we can improve this with something called AMD. AMD is a specification for how to define modules. It provides two functions fundamentally, define and require. So this is a module definition and uses define. When you call define, you'll get two arguments, but essentially just wrap the whole thing in define. Each of these has to be in its own file. So modules match up exactly to files. And you just pass it straight through here. They map to files because you specify dependencies as the first argument, and the name of each dependency is just a path. So there's a root that you use from which to base your paths. And then here we're saying within that there's a lib folder that contains jQuery.js and knockout.js. And there's a coffee machine folder with command.js. And you can load these in, just provide a list of things you want, and it knows where to find them and it goes and gets them for us, which is quite nice. You then define an actual function. So this is equivalent to what you're doing with ifs before. So we then bind each of these dependencies to variables here. So we can give them whatever new names we like. We don't have to worry about namespace with massive parts or whatever. We just take it down to the most simple dollar, this kind of thing. This function doesn't get immediately run. So the asynchronous part of this is that here we've said we've got a function, this defines a module, it depends on all these preceding modules. What then happens is it says, okay, that's great, it goes loads all of those, brings them in, then in turn have defines and transitively follow this until we've got a graph of all the dependencies. And then we can start pulling in the scripts and running them as soon as we have the values for all the preceding modules. So, for starters, this means that we can run the actual HTTP requests completely in parallel, and put everything in all at once, and then start running it in order that we know is going to work as we think about it. And it just means that you're quite safe. There's no point where something you depend on is ever possibly not going to be available. Or that everything depends on dependencies. And then once you actually run the function, you return whatever you like as the value of your function. So it can be an object, or it can just be a function, or just a number, whatever it is. There's also a required. This is basically what you do if you aren't actually defining anything. So you cannot return something from a define, but then you just end up giving your module a value undefined. Requires don't have defines, or certainly we don't use them, you can give it one. And you also don't have to put them in their own file. So this tends to be the entry point of your application. Doesn't require, it depends on everything you actually need, and then kicks it off, and then each of those are individual modules separated out depending on who each other goes through. I'm actually showing off a little bit here, because these aren't depending on normal things, but are depending on plugins. So if you've got an explanation mark in the middle of these, and here we've got a font plugin and a less plugin, DOM ready plugin. And this will actually go and make sure that font is loaded and available in the browser. The less plugin goes, loads less, compiles it at runtime, CSS and includes it in the browser and ensures that's available. And the DOM ready plugin will let you wait for an option JavaScript event or DOM ready. So none of these actually return variables, so we don't bother. None of them return values, so we don't bother setting up parameters in our functions, but it lets us through this plugin mechanism, which is actually really quite easy to use. I've written plugins in it, so about an hour, it's fine, from when I had no idea how to work. It's really quite easy to do, it's quite easy to use, it means you can depend on basically anything. Anything that can go off and happen asynchronously, and AMD can run it when you're done. Just kind of works, which is really useful. And then this is what it looks like at the top level. So AMD is a specification. You have to have a module loader that, now that you've clearly defined exactly what you depend on and where to get it, can go and actually get it for you and hook it up and so on. This is using require.js, which is by quite a long way at the moment the clear leader here. Basically everything uses require.js. All you do is include one script tag rather than n, as before. You specify a main file, which is the place to start. And this just gets loaded and says, I have a coffee machine, give it to me, and I will start it. And the coffee making machine can depend on whatever else it likes, that can depend on whatever else it likes, and all of those things automatically get loaded, prepared, set up, rather than return some kind of value, a coffee grinder, a set of needs, before we get to this point. And then as we start to write, everything's up and ready to go. Maintaining this going forward, you don't ever have to add any scripts to this, as long as everything you're using is AMD. As soon as you want to add a dependency, you just add it to the place where you're going to use it, and then it just works. It's amazing. So yes, this gives us all the 3 bits I was originally looking for. Stuff is encapsulated because your backend functions again. We've got this nice little local scope. No locals as far as possible. Stuff is reusable as long as paths match. You can actually erase them as well. So you say that this specific path actually means go look in the jQuery. So you can handle that. Get a bit there. All those package managers that actually define quite specific folder formats where they all follow the same format. It just kind of works. Dependencies are explicitly named. You go in, they have to be in the top file. You just look, you can just see. It's great. Dependency loading being asynchronous is actually quite nice, and lines up with how everything else works in browsers on JavaScript. Asynchronous stuff is kind of the standard in JavaScript at the moment, really. Single-threaded applications really like that whole cool back and forth kind of model. That's really nice. It's quite good being able to do press and parallel. And it's all just JavaScript. So you include require.js, but there's no particular magic going on here. It gives you 2 functions that do some not insanely complicated things. And that's quite nice. There's nothing particularly crazy here. It does have some downsides in that there's a lot of boilerplate, so you've got this massive chunk of stuff, but you end up sticking around everything. If you're building lots of small modules, it's a bit annoying. People complain about this, but I don't think they've ever written Java, which is much worse for this kind of thing. It's quite complicated, there's a lot of bits to work out there, and plugins and stuff, there's a lot in the module really. Circular dependencies actually are one thing where this doesn't really work particularly well. If you have a module A depends on B, and B depends on A, it will give one of them an undefined value for the dependency. And log briefly, which is quite annoying. Also, it's actually really easy once this becomes very simple, you can just stick together loads of modules. It's really, really easy to just have absolutely loads of them and have an application that starts up and just fires off HTTP requests for a while. But there's actually some other tools, RJS being one that is part of the require.js framework, that will statically analyze your whole thing and sort of final build tool step, just bundle it all up together into a single file that you can just load, which has everything pre-set up, which is a bit of an improvement. But there are other options for many ways of JavaScript. So CommonJS, the CommonJS group are a group of developers essentially trying to build a standard platform of JavaScript conventions and specifications that are going to move everything forwards a lot more. So they're both looking at modules and stuff like promises, this kind of thing that people might have heard of. And it's all under the CommonJS umbrella. They're quite server focused by and large. They're really looking at things like Node.js. Really. But it's nice. This is what a CommonJS module looks like. It does some strange things. Specifically, this does not follow normal JavaScript semantics. So CommonJS requires that every file actually is independent. You don't have any globals. The reason that these are local variables is because we're going to throw away the old rules, and now these are local variables. That's a bit strange. Some people kind of don't like that, I don't know. But essentially, the actual model is that you have this exports, I guess, global. It's a very, you don't have to define which is there. If you simply attach things to it, the exports value, then the exports object, then becomes the return value from your module. So this is what other people will depend on and get if they try and require you. You could, alternatively, you can just replace the tile. You can do module.exports equals something completely different. And not attaching stuff to that. If you just want to return a single object, rather than attach properties to this. Once you've actually done that, you can then require things to export in that way. And it just gives you the exports object right back, or you can get it back and pull all the properties of it. It's sort of standard way. There's nothing particularly crazy here. These don't have to be on top of the file, so you can sprinkle them through anywhere, which means you can do cool things like if, blah, 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 then go and provide it. The reason that works is because these are synchronous. When you hit this line, it stops passing this JavaScript. It goes and it finds jQuery, it passes all of jQuery, and then if it suddenly requires it there, it goes and passes that, it runs all of that, and then it comes back. This is interesting. So it can potentially block for quite a while, and obviously if other modules explode, then you explode in turn. Also, certain dependencies actually get handled a bit better here. So the exports object is pre-existing. If you require this, it gives you a reference to the exports object. It's not yet actually set up, so it doesn't have any properties attached to it, but it is an existing object. And if you wait until this finishes, then the other module you have a certain dependency with will also finish, and they will get attached, and you'll still have a reference to the object. If you depend on something that depends on you, you just can't quite use it until you get called in a function later, but you can get hold of it and start actively trying to get at it, which in AMD is actually really surprisingly difficult. So, this doesn't follow normal browser JavaScript semantics, so you have to run it with a special runner. Normal browsers will do not things that you expect if you try and give it this. So, there's a few options for this. The big one is the various non-browser JavaScript platforms, and the big one of those is Node.js. Node.js is fun and exciting and really into CommonJS modules as a format. CouchDB also supports them, and Null, which is the JavaScript runtime, and Zorjet, which is Mozilla's JavaScript runtime. So they're getting actually a whole long list of others. So they're getting a good bit of uptake, and this is kind of the real native environment for JS modules, because synchronous loading really only works well when loading is cheap. When you're it's quick, it's loaded. If you just put something to the disk, comparatively that's fine. But if you need to go and hit another web server somewhere and pull in a whole file, that is going to be quite a lot more painful. And also this is kind of close model to what you get in other languages in the same kind of competing with Node.js. So things like Ruby and Python, you do just go import X from wherever, and it just goes and gets it and it comes back. So it's much more of a standard feel if you're looking at that kind of thing, server-side modules particularly. You can also use Browserify, which lets you bundle up CommonJS modules. So you write just CommonJS modules just as they are here. You run a build set that then goes through all of these at the end and writes JavaScript around them to generate the semantics that we need. So it creates an exports object, sets it up for each one, and it goes and it handles requirements, and it provides you with this model around it. And then this compiles it all into a single file, so you get the same type of benefits of RJS, and it lets Node.js modules work directly in the browser, which is quite cool. Node.js has actually got like big now, NPM, which is the Node package manager, has a lot of packages. You can just pick one and use them in the browser, which is neat. There's suddenly this whole ecosystem building up as opposed to just half of the script files. And Require.js, which I mentioned before as an AMD script loader, actually will also do CommonJS. Badly. So it takes a require and exports function, and if you just don't define the dependencies and ask for a require and exports function, it will give you some. They act in the same sort of way. But what they actually do is take this whole function, turn it into a string, search for every bit where you say require in a string, asynchronously load all of those, and then give them to you when you actually get to that line. So you can get into all kinds of trouble because it's not thinking about any of the actual semantics of it. If you actually have another function called require, I think you can really find yourself. If you wrap it in a conditional, you're going to end up always loading it when you think you can maybe load it, this kind of thing. It's quite hacky, but it does technically work. And you can turn CommonJS modules into AMD relatively easily by just slapping that at the top of the bottom and this kind of thing. This has got a lot of benefits. Everything is encapsulated as before because we've defined everything encapsulated. Dependencies are explicitly named, anything that requires, the code is nicely reusable, back and forth. CommonJS doesn't actually define what the IDs mean at all. So they might be passed on a disk also between IDs in the database, or if they prefer purely to name or front page managers in some way. But nodes generally makes them match sort of paths. So it has this modules folder that goes down. It's got, so code is quite reusable because you've got this quite flexible ID system. It's got quite nice clean syntax. It's very simple, require export. You get it, just it works. There's not a lot going on there, it's a real boilerplate. And it does circular references to player languages, which occasionally comes up and it's later. But there's a lot of magic. It's not JavaScript. It's something really JavaScript. It doesn't follow JavaScript code conventions, which if you're quite familiar with JavaScript is going to be quite uncomfortable. There's no consideration of environments where actually loads are quite expensive. You don't want to get these different times which will hurt you. It ignores asynchronous JavaScript completely, it just does everything at the same time. And dependencies are really obvious up front. So you can sprinkle requires all the way through the code, and then you don't get that bit of easy to put it in. See what it means. So I have a third and final wonderful module option for you, which is ES6 modules. ES6 is the ECMA script 6, which, as you may recall from my history recap, is the official name for JavaScript. And this is the next upcoming version of JavaScript. It's still a spec. It's not even a final spec. It's a working implementation. But this is what it looks like, and it's going to be pretty close to this, fairly likely, and it's going to be around not that far away. And certainly there are a lot of open source projects trying to provide reference implementations and get them there, and trying to provide transpilers and this sort of thing to let you use this now. What this actually consists of is a module wrapper. This is a new keyword rather than just new semantics. You wrap things in a module. You have to wrap it in a module if it's inline or if it's a nested module, both of which are things that the others cannot do. And if you do inline or nested modules like this, then you explicitly give it a name and you say what your module is called. If you do it as an external module, then the name is the file name, as we're going to do. You export with an export keyword rather than some global var with new semantics. And you just put export before the declaration of the variable. So here we need export a function that does some stuff. We export this variable, is a number. And these then become properties of the object that are module returns. So like with CommonJS, you have this exports object with attached properties. Here, we're going to have a module object that is us with attached properties, but you can't actually see it. It's just this implicit built-in. So, imports, you can import in quite a few ways. So, if you import $from jQuery, it just gets the whole object from jQuery with whatever is attached to it and renames it to $, gives that to you as a local variable. You can import parts. So you can import parts of objects and rename them. So here we go in, we're getting the nice beans property and renaming it to lowercase nice beans in our little scope, so we get that. Or you can just try and import a whole function as a name. And if you do that, it gets the default value. So you can provide an easily exposable thing and just name it what you like. This is rather than, so if we were importing jQuery like this, to actually do anything with jQuery, we have to do dot, whichever bit we want to get at. If you're clearly exposing one thing, like a constructor or jQuery select method, then it's quite nice to be able to default to do that a little more succinctly. These are nice, and eventually are actually going to be really well supported everywhere. This might not be the exact final format, but 5-10 years from now, everything's going to be doing this everywhere in JavaScript, assuming people still want to use JavaScript. It's gives you quite a lot of powerful control over reports, which is actually quite nice. You can play around and get a lot of filling little bits. I've missed out on other ways of doing reports there. There's really a lot of different mechanisms in here. And it's adding new syntax, so we're getting these new keywords, but it's not new semantics. So it's not changing existing semantics. If you can run this as part of an existing JavaScript runtime, and it won't break any existing values of JavaScript code. Whereas CommonJS obviously changes what things mean that already exist. This is just adding new keywords. With these new keywords, there's very little boilerplate. It's nice, simple, export, import. Circular references work even better because, as far as I can tell, you have to put export next to the actual definition of the variable. In JavaScript, variable definitions get hoisted all the way to the top. So when you export everything, you find all the actual names you're going to use before you do anything, really. So you can depend on module.copy grinder before the actual module has finished running, and the module in turn can depend on something in your code before you've finished running, and both of you will get the objects that once you both finish defining, you can actually use. So that's basically as good as you can make it, and it's quite nice. And this is even closer than CommonJS to other languages. So this is directly got a lot of Python, almost the entire language. The surrounding module syntax, which is directly pulled off Ruby. It's a nice model, it's very clean, it's very clear, and it's got other nice features like inline, ES6 modules, which again is a kind of Ruby thing, as well as being able to do external modules like AMD. But still, it has some downsides, like absolutely you cannot use this. So it's not effectively supported anywhere, really. You'd have to include some libraries that are still in substantial development, and your code might become invalid when someone decides actually they don't want to make it work that way. So this isn't a particularly good idea to use right now, but it's definitely something that you're going to need to be prepared for if you're writing a lot of JavaScript on any real scale in the reasonably short future. Also, there's a lot of new syntax. JavaScript as a language is just going to get bigger and bigger and bigger. We have to keep backward compatibility, so we just keep adding features and we never take everything off, which seems dangerous. An import star is included. Every single language that I'm aware of has decided this is a bad idea and nobody should ever use it, but they've added this spec as well, which brings back the problem of global name collisions, or variable name collisions, because if you import star from some other module, it can define something new you didn't realise, and that can write over some variable you were about to use with the same name. So yes, it's quite powerful, it adds a lot of these things, but it is quite complicated with these different ways of managing imports and default versus normal imports and this kind of thing. That's all the options I've got. Mostly, cutting the chest, mostly, for most JavaScript going on, I would suggest AMD because by and large it's fairly well supported. You can actually run, there's a node for JS module, so you can run it if you want, and most stuff is happening in the browser and use reasonable browser networking. If you're writing really small projects though, you just want something quick and easy, IFIs are actually pretty good. Until very recently, so maybe 2 weeks ago, a month, jQuery was distributed as an IFI entirely, and you had to wrap it as an AMD user. It's now just moved to AMD. They're also just quite easy. You make one stick as a script, it works, no trouble. It will bite you as you get bigger, but for small projects it's quite simple and convenient. AMD is nice, you don't have to build anything, it's just JavaScript. There's a bit of boilerplate, but because of that, it can do lots of cool stuff. You don't depend on these plugins to do crazy, all sorts of magic things. And it's a nice, clear model. CommonJS is actually really well supported in most of the non-browser environments. So Node.js, CharacterD, etc. It works really quite well there. The ecosystem is getting really big. NPM actually gets a lot of new modules published every day and a huge number of downloads. And works really well to get towards an actual serious mainstream language. And anything in the browser where you actually want to use any of this ecosystem as well, because being able to draw in from that, that's a huge set of useful bits and components that you can suddenly pick up if you move across to CommonJS. And then ES6, basically, if you really want to be prepared for the upcoming stuff, or you want to get on the cutting edge, all of the people trying to build reference implementations, this is all open source, you can just get in and join in. As is the spec process, it's just a lot of people discussing controls and mailing lists. So if you want to get more involved in that, you totally can, and it's going to become very for the next couple of years at least, you don't want to build it. And then at that point, you have to go with that forever. And that's all. Thank you. Do you have any questions?
If I adopt one of these approaches and then come across one of my favourite JavaScript libraries, which is Interactive, how easy is that to implement?
So, there are quite good wrappers for most of them that will let you import the others. So require.js will let you use common.js ones. Common.js, there is a require.js no module, so you can end on that and do that. They're a bit of hassle, and you try and avoid it generally, but sometimes it's just not avoidable, and actually it's not that bad. There's also relatively good transpilers to convert back and forth between them that work reasonably well.
So that's if it's from one system to another.
Yes.
But what if it's some scanty script off the web that I like and that would be used?
So, the poster boy for this is jQuery, very recently, because everyone was doing this. What people mostly did was somebody re-released it with AMD Benefits, which actually works really well, it's really easy. You can also, so require.js has a shim system, so that you can say, there's this global and a global environment, pretend it is a package with this name, and then you can depend on it, and when it actually becomes a real package that you can use, and then it will be there. And I think common.js has a similar sort of system, but it's a bit more tricky than that. So.
The ES6 import, the async.
Yes, but it's still.